Hello, YouTube. This is UMOS03. So for multiple lessons now, we've been building up an understanding of linked lists and collections in general, right? The collections class. The idea that we could have a sort method to basically sort an array list or linked list. So what we're going to be doing in this video is reviewing a lot of the fundamentals that we've been talking about in recent videos, but I also want to say a little bit more about stacks. And then in this video, we'll also talk about queues, which is another type of advanced data structure. But in this class, I created a class called Queue Practice. And so we're going to be practicing not just with linked lists and with stacks and collections and iterators, but also with queues, which is a new type of data structure for this video. What we're going to do is we're going to look at a class that I made with a bunch of static methods, and we're going to study these static methods and basically get a sense of what's going on with each of them. In this static method, what we do is we have a static method which doesn't accept any inputs, but it's just called generate list, and it accepts no inputs, but it returns a linked list of egg objects, right? And we talked about in previous videos, we created this egg class where we basically go ahead and instantiate two instance variables at the time that the object is created. And then we can pump A and pump B, which basically just means add one to either of those instance variables. In the compare to method, if we try to compare two egg objects or sort an array list or linked list of egg objects, we would do it basically by looking at the resolve method. So is the result of A minus B less than, greater than, or equal to the result of some other egg objects A minus B? So hopefully that's clear to you, but that's how we defined it in the compare to method, and that allows us to sort egg objects. So hopefully that's clear to you. But what we would do here is we would basically be looking at a linked list. So what we would do is we would generate a linked list of egg objects. And we said in order to create linked lists, you have to go ahead and import java.util.Linked List. So go ahead and import these 5 things. We haven't talked about queues yet, but these are the 5 classes, the 5 important classes from Java that we need to import at the top of our class file if we want to be able to use them. So we create a linked list, and we have 10 egg objects, and we're calling on the constructor where we create an egg object by passing in 2 int inputs, right? 2 int parameters. And we're just going to go ahead and add those 10 elements to the linked list, right? Add each one to the end of the linked list, essentially. So it's just going to be E1, E2, E3, E4, E5, and so on, right? And then you're going to return that linked list. So it's going to return a linked list with 10 egg objects in it. That's all that this static method does. That's what it returns. Okay, and so that's what this method does. And then what we can do is we can think about sorting an array list or linked list. So what this static method does is it says print sorted of linked list of type egg, my list. And so if you pass in a linked list of egg objects, we call collections.sort of my list. And basically what we said is that the collections class has a static method called sort. And so you could go ahead and look in the API. You could go to blackle.com and type in collections Java API. And you would look at the class API, and you would look at basically this method right here. So it's a static method. It's a static void method. Okay, so it doesn't return anything, but you call the function and basically it sorts the list. And you could be talking about either an array list or a linked list, but this particular static method accepts a linked list. And you would say collections.sort of my list, and then you could just print the sorted list to make sure that it's sorted. So you'd say for egg R in my list, for each of the eggs, print the egg, right? And we talked about how we would use the toString method of the egg class. And what would that look like? Well, what we would do is we would go to the egg class and look at the toString method, and it says return egg tester.print egg of this. So basically we would have to look in the egg tester class and look basically for a static method called print egg, which accepts an instance of the egg class and returns the string this egg has a resolution of, and then the result of the resolve method for the particular egg instance that was passed in to this static method. So really for a particular egg instance, we're just going to print this egg has a resolution of, and then the result of that egg instance's resolve method. So hopefully that's clear to you, but we're going back to here now. So we would just print the eggs in the linked list, right? It would just print the sorted linked list. So hopefully that's clear to you after calling collections.sort of my list. So this is an efficient sort for an array list or a linked list, right? And we talked about this in a previous video. You just call collections.sort of an array list or linked list. We also talked about the minimum and maximum elements, right? So if you pass in a particular list, array list or linked list, you could say collections.min of my list or collections.max of my list, right? And according to how your compare to method works, according to what you defined it to mean, to say one object is less than another object, one instance is less than another instance, this will give you the least of them, right? The minimum element, and this will give you the maximum element, however that's defined in your class. So hopefully that's clear to you what would be returned by those, what would be printed by those two methods. And then we also talked about iterators, right? So we said in order to use an iterator, you have to go up to the top of the class definition and say import java.util.Iterator. But if you do that, you can say iterator of type egg dairy parse equals, and then on a particular array list or linked list, you call w.iterator, right? If the linked list was called w here, in this case, that's the parameter name. So you'd say equals w.iterator, and then you say while dairy parse dot has next, so while the name of the iterator dot has next, and then you would say system.out.println of dairy parse dot next. But basically the dairy parse dot next, if you call iterator dot next, it would refer to the next element in the array list or linked list, right? And you could go ahead and print the string representation of that egg object, right? You could go ahead and print that element, right? And then in the previous video, what we did is we also said that if you say dairy parse dot remove, if you call it, on the iterator dot remove, it would remove the element from the linked list, from the array list or linked list. And so we went ahead and verified that. We removed the elements as we iterated through printing them. And then at the end of doing that, we verified that the list was empty. But hopefully the array list or linked list that you passed in would eventually be empty if you were calling the remove method over and over again. But you can only call the remove method once each time you call next. So hopefully that's clear to you. And in the previous video, we talked about stacks, and we said basically a stack is a type of data structure which is last in, first out. And we could think basically about a stack of plates where we keep generating plates on top of one another, right? And so we can only add and remove from one side of the stack, right? If you're putting plates on top of one another, then the most recent plate to be removed is going to be the most recent one to be added is going to be the quickest one to be removed, right? And the last one that came in is going to be the first one that comes out. So hopefully that makes sense to you. It's called last in, first out. But we would say stack egg, stack one equals new stack, right? And this is how you would create a stack object, right? It declares and initialize a stack where the elements in the stack are going to be egg objects, right? And so we create the same 10 egg objects as we created for our linked list. And then we can go ahead and push them. So we said that basically you would call on stack.push of, and then you could pass in an element to add onto the stack. And we saw that in the previous video, right? Where we were looking at the egg tester class. And basically the code that we had is we had a stack of eggs, right? And we said my eggs.push of E1, my eggs.push of E2. But this is how you add an element onto the stack. And then what we did is we said, while it's not the case that my eggs.empty, right? So for a particular stack, we have a method called empty, not isEmpty, just empty, which returns a Boolean or returns true if the stack is empty, if it has no elements left in it, right? And we would want to keep popping off the elements until the stack is empty. So now we can talk about pop, right? So anyway, push is for adding elements onto the stack. And so what we could do is we could say show stack after push, right? And we could basically accept an existing stack and then a new egg to add onto the stack, right? And then we could say my stack.push of new egg, right? And then we would basically want to go ahead and print the stack again. But the point is that iterators can also be applied to stacks. So what you could also do is you could call my stack.iterator, because stack is a data structure. Stack is a class in Java that implements the list interface. And one of the things we said is that the list interface includes a method called iterator, which returns an iterator object. So the goal here is that you can also create an iterator object for stacks, okay? And so that's what you would do here. And so basically that would basically enable you to print the egg objects in the stack, right? In the previous video, we said, while it's not the case that the stack is empty, print stack.pop, right? You would just pop the elements off of the stack, which is what we're talking about, which is what we'll talk about in a minute. But you could also just create an iterator, and you could say, while dairy parse.has next, system.out.println of dairy parse.next. Okay, so that would basically go ahead and show you the elements in the stack after you pushed an element onto the stack, after you added a new plate onto the stack of plates. So hopefully that's clear to you. And then we have show stack after peak. So what if you wanted to look at basically the top of the stack, the front of the stack, without removing the element? And we said basically what peak does is it returns the top of the stack without removing it. So that's what we talked about in the previous video. But you could go ahead and peek, and you could say, okay, this is going to be the egg to peek at. And then we would go ahead and look at the top of the stack, right? And then we could go ahead and create this iterator object again, just to make sure that no elements have been removed from the stack, just to make sure that as a result of calling peak, we only looked at the top of the stack without actually removing it. So hopefully that element would still be preserved. Like hopefully the top of the stack would still appear as, as we iterate through all of the elements in the stack, because we just return it and peak without removing it. So hopefully that's clear to you. But the difference with pop is that with pop, you actually return the top of the stack and remove it. So if you say egg to pop off stack and you say my stack.pop, this would go ahead, and then you could go ahead and iterate through the stack again, right? But then hopefully, the whatever egg object was returned by the pop method would not appear when you say, system.out.println of dairy parse.next within this while loop, right? Because the element that's being returned is also being removed if you call pop instead of peak. So hopefully that makes sense to you. And then we also briefly talked about this search method, right? So we said search will basically, it's sort of like an index sub, but it would return the index position of one of your elements in your stack, right? And we basically said that if an element exists at the top of the stack, so essentially if it was the most recent one to be added to the stack, then this search method would return 1, right? So basically 1 for the top of the stack, right? And then 2 for just below that, and then 3, and then 4, and then so on until you were essentially at the bottom of the stack, right? The bottom of the stack corresponds to the elements that were added latest. So hopefully that makes sense to you. What we're going to do in this video is talk about queues. So queues is another type of data structure. And I think what it would be helpful to do is to go ahead and just do a Wikipedia article. So what you could do is you could go to blackhole.com and you could look at the document, or basically you could either look at the documentation for a queue, or more generally, you could look at the Wikipedia article, right? And you would be looking at an abstract data type. You'd be looking at a data structure. And it says in computer science, a queue is a collection of entities that are maintained in a sequence and can be modified by the addition of entities at one end of the sequence and the removal of entities from the other end of the sequence. What I would do is I would think of like a line at a supermarket, right? You go to Walmart or something, and there are people in a line, right? They're essentially people who are first in and first out. And that's what it's going to say in this Wikipedia article. But basically you have these people lined up, and the person who's working the cash register is going to serve the people who appeared first, right? The people who were inserted into the queue first are going to be served first, right? And the people who are coming in first are going to be served, are going to come out first, right? But the people who are coming in last are going to come out last. This is called a queue. And you can see how this is different from a stack, right? Where in a stack, we were pushing and popping elements off of the same side, right? But with a queue, we're going to add elements onto one end of the data structure, and we're going to remove them from the other end of the data structure, right? So the first element is added to the queue will be the first one to be removed, right? And so this is different from a stack, right? But this is called a queue, right? And so basically NQ is when you're adding an element to the queue, and then I guess DQ is when you're removing it from the queue. But basically what we're going to do is we're going to generate a queue. And the way that you do that, the first thing that you have to do is you have to say import java.util.Queue. So you need to go ahead and you need to import the queue class at the top of the file, okay? But what we would understand is that queue that is an interface that supports a linked list. So in order to generate a queue, what you're gonna do is you're basically gonna say queue of type egg, q1 equals new linked list of type egg. So basically you would say queue and then of object type, and then you would say name of queue equals, and then you would say new linked list of, and then that object type, right? And then empty parentheses. Okay, this is your default constructor. But what we could do is we could create those 10 egg objects again, right? The same 10 objects that we put into the stack and the same 10 objects that we put into the linked list, but now we're going to put them into a queue. And we want to understand the operations of a queue, but you need to basically create an object that's declared as a queue and initialized as a linked list. You can't initialize it as a queue because a queue is an interface. And we were talking about abstract classes and interfaces in previous videos, and we said you can't instantiate an interface or an abstract class. You would actually have to instantiate it as a linked list. But this is a new data type, right? Don't think of it as a linked list in general. Think of it as a queue in particular. And so basically the point is that to add elements to a queue, it's going to start out as empty, but then you're going to say q1.add a v1 and q1.add a v2. And then think about these eggs as being like customers in a line. So if you're going to remove elements from the queue, instead of removing E10, right, which is what you would remove if you were talking about a stack, right? If you were stacking on E1, E2, E3, E4 on top of each other, then the first element you would remove was the last one that came in. So you would remove E10. But with a queue, you're going to remove E1 because E1 is the first one that was inserted. And that's the difference between a stack and a queue, right? In essence, they're sort of opposites of each other. But what we're going to do is we could generate that queue and just return it. And so you can see the return type of this method is queue of type egg, right? And then you could show queue after add, right? So if you pass in an existing queue and a new egg that you want to add on to the queue, you could say egg to add to queue and then new egg. And then you would say my queue.add of new egg, right? Same thing that we saw when we were just generating the queue for the first time. But the point is that you call the .add method, unlike with stacks where we called the .push method, right? So this is a little more like a linked list where we call .add instead. And then you can have an iterator, right? So iterators can also apply to queues, okay? They can also apply to queues, right? So you can call an iterator object to iterate on an array list, a linked list, a stack, or a queue, right? So you would say iterator of type egg dairy parse equals my queue.iterator, right? And then it would work the exact same way. You would say while dairy parse.hasNext system.out.println of dairy parse.next, right? And then you could show queue after peeking, right? So remember in stacks, we talked about how there are two operations supported, pushing and popping essentially, right? You can either add an element onto the stack, or you can peek at the top of the stack, or you can pop the top of the stack off, right? With peek, we're just looking at the front of the queue. So we would just be looking at the first person in line, but not serving them, right? But we would just be looking at the peek at the front of the queue, right? And so that's what peek does, is it returns, but does not remove the head of the queue. So hopefully that makes sense to you, but it kind of works the same way as it does for the stat class, right? And then you would again create an iterator object just to make sure that by looking at the head of the queue, you didn't remove it. So we would still want the head of the queue to be the same as before we called the peek method, right? Peek doesn't actually alter the queue. It just looks at the head element. So hopefully you understand what the peek method does, right? And then there's also the pull methods. This is the last one, but the pull method would basically remove the head of the queue and return it. So returns and removes the head of the queue. So if you say my queue.pull, not only would it return the first customer in line, the first egg that you added to the queue, but it would also remove it. So that customer would be served, and then they would no longer be the head of the queue. And then you would just create an iterator object again based on the queue. And then you would say, well, dairy parse.hasNext system.out.println of dairy parse.next. So we can create a main method. What I'm going to do is I created a main method where I have an original linked list, right? And we can go ahead and make sure that, remember, we created a linked list in the generate list method. This is one of the methods that we were talking about, but it just returns a linked list with those 10 egg objects in it, right? And we can just make sure that this is going to work as intended. But I just wanted to test out some of these static methods and show you what's going on here. So now if we go ahead and run the main method of this class that we built, and then we would basically want to go ahead and look at the terminal window. So what we can do, I just want to scroll up. I know we only have a minute. So we have an original linked list, right? We generated a linked list with 10 egg objects, right? And this prints the result of the resolve method for the 10 of them, right? And then we called collections.sort of lists, and you get a sorted list, right? And then collections.min of lists, collections.max of lists. Those work as intended. And then we can also have an iterator, right? So this demonstrated that you can use an iterator object to print the elements in a linked list, right? And then we printed the initial stack. So we created a stack and printed the elements in them. And then what we did is we said, we're going to push an element, an element with a resolve of 555 onto the stack. And you can see that right here, right? And then if we peek at the top of the originally generated stack, then we get the 2, right? Because that was the element that was at the top of the stack that was originally generated, right? But if we pop off the 2 and then look at the stack, then you can see it's removed, right? And then we want to talk a little bit more about stacks and queues in the next video, but at least hopefully you understand the difference theoretically, and we'll just pick this up in the next video. But from UMOZO 3, I think that's enough for now. Thanks for watching, and please subscribe.